We are hosting a particularly distinguished birder tonight. Peter Pyle is an ornithologist, a marine biologist. He started his career taking part in the Hawaii, Micronesia, and Samoa forest bird surveys. And he then moved on to research birds and white sharks at the Farallon Islands in California. He told me tonight that he loves blue and windy and cool, so the Farallones are a perfect spot. He developed a special interest in bird molt and how it can be used to age birds, and has published papers and taught workshops on this subject in both North America and Latin America. Among bird banders, he's best known for his identification guide summarizing molt, aging, and sexing information for North American birds in the hand. He's a research associate both at the California Academy of Sciences, San Francisco, and at the B.P. Bishop Museum in Honolulu, Hawaii. To date, he has authored over 120 papers in scientific journals and 3 books, and has been a co-author on an additional 70 scientific papers and an online monograph on the birds of Hawaii. He currently works for the Institute for Bird Populations in Point Reyes Station, California, and joins us from Sebastopol tonight. So thank you very much, Peter Pyle.
All right, thanks, Judy. I see a lot of names, or no, a few names I recognize. Hi, everybody. Yeah, I'm actually in Petaluma. And the Institute for Bird Populations moved, as I was telling Judy. The first week of March, we packed up, moved, got here, and then the office got locked down. So I have yet to decorate. That's why I have such a nice backdrop. I'm sure I'd get a 0 on the rate your room thing. So anyway, welcome. What we're gonna do is this is a talk I gave a lot in the 90s and 00s, I guess, when I was involved in this research. So I'm not really involved too much in the research that I'll be talking about today, but I have kept up with it a little bit. I gave this talk, as you'll see at the bottom, to the Ohlone Audubon Society on the October 6th this year, and I believe they just posted my talk, pretty much same slides. Online, so you can go to that. But as I always say, you know, you guys both asked me about the same time, and I gave a list of the different talks I give, including Adventures in Bird Molt, but nobody wanted that one. But you both chose the same one, this one, from a while ago when I was working a lot in the Pacific on migratory animals. So that's what you get. But as I tell, when this happens and I give the talk kind of close together, I never say the same thing twice anyway. I pretty much ad lib it all the way through. And if you know, nobody will be this masochistic, but if you wanted to see my talk and then go on to the Ohlone one, you'll probably get a whole bunch of different stuff. So anyway, here we go. Let's see. Oops, now my buttons aren't working. So how about this? Oh, resume slideshow. Okay, oh yeah, that. Okay, here we go. So I've had the fortune in my life to work on 2 really cool islands, Midway, and I presume you can see my pointer. I like to point stuff out. Here in the Central Pacific, it's located about 1,200 miles west-northwest of Honolulu, and is one of the last, it's almost the last of the Northwest Hawaiian Islands. And then the Farallon Islands, I've spent 24 years working on those here off the California coast. I think this X was in the wrong place slightly. So we'll start with Midway. It's an atoll, and it's pretty famous as a site of our naval station back in World War II. The Battle of Midway and all was the turning point in the war, at least in the Pacific theater. So there's a big old runway there where they used to run reconnaissance flights, the Navy and all that. But in 1997, they turned it over to the U.S. Fish and Wildlife Service. So it's now the Midway Atoll National Wildlife Refuge, which is great. They still operate the runway there. This fringing reef is 44 miles in circumference. And there's 2 islands on Midway. Here's the main one, Sand Island, and this one's called Eastern Island. It actually there's a little one called Spit. And I was there in the late 90s and early 00s doing research, helping set up seabird monitoring on Midway with the albatross and several other birds nest there, which we won't be talking about too much, but bone-in petrels, wedge-tailed shearwaters, 3 species of boobies, frigate birds, and so on are all nest on various parts, a lot of them here on Eastern Island, which is uninhabited at the moment. So the geology is kind of interesting. This is a fringing reef. The way this works is that the plate under the hot spot. So the hot spot in Hawaii is now southeast of the Big Island and is pumping up lava, and the plate is slowly moving west-northwest. So as the plate moves, the hot spot forms islands like the Big Island now, and then as the plate moves to the west-northwest, and also sinks, the mountains and islands sink, and then by the time they get to 1,200 miles where Midway is, the actual top of the island is 600 feet below the island itself. So the mountain's gone, but what happens is the coral forms a reef around what used to be the mountain, and then as the island sinks, the coral continues to build on top of itself to keep the atoll alive. And so you can imagine a column of reef here that's about 600 feet deep under Midway. It's pretty cool. And it's almost reached what they call the Darwin line, which is about 30 degrees latitude. And at that point, there's not enough solar radiation per year to keep the coral going, so the atolls die. And actually, if you follow the Northwest Hawaiian Islands, they extend they're called the Emperor Seamount after that, and they extend all the way up to the Aleutian Islands in Alaska. So the plates in that hot spot that currently is forming the Hawaiian Islands has been going for quite a while. So the two birds that attract the most attention there are the albatross that breed there, the Laysan albatross and the black-footed. And ecologists for a long time always wondered why 2 species that are so similar in structure and form and presumably feeding habits, or at least food resources, can nest side by side. That's an ecological question that is of interest, because normally when you have this situation, one species will eventually outcompete the other, and natural selection will cause one of them, the one that's not favored, to go extinct. So this is an odd situation. So the question was, how is this, and how is this occurring, and why? And that's a question we'll answer. Now we see the black-footed. In fact, Judy was just mentioning a couple we're seeing during those gales on Sunday from shore down there, which is pretty cool. And we see those in Monterey Bay and off the Pacific here, but it's this one, the Laysan, which we don't see so much. We see it in the winter a little bit farther offshore from California. That's about 20 times more abundant than the black-footed. So the population of Laysans is probably in the 2 to 4 million, maybe more. And then by now, because they've been increasing, and then the black-footed's only about a 20th of that, a couple of 100,000. And on Midway, there's 600,000 breeding Laysans and 22,000 breeding blackfoots. So they go through this elaborate courtship dance, which is kind of fun to watch. And there's been a lot of good papers on the behaviors here, and they've videotaped it and slowed it way down so they can figure out every move. And there's 3 reasons why these birds do this. The first is to make sure they're selecting the correct species. And so when you look at them dancing, here's kind of the typical Laysan albatross dance where they're doing all of this. They go under their wing, they give a little whistle, then they both usually go up like this and give a moo call. It's really fun to watch. And the whole island in November is covered with this activity. But then when you get to the Blackfoots, they have a completely different style, okay? So if a Laysan and a Blackfoot walk up to each other and try to dance, it'll be like doing waltz and the twist, and they'll look at each other and go, nah, and then move on and find a dancing partner that dances with them more conveniently. The second reason is to make sure that they're going to select the right sex. And actually in those videos where they've really slowed it down, each sex of each species has its own slightly different moves. So they recognize those moves, and when they're forming their pair bonds, they want to make sure that they're going to mate with the opposite sex, or they're not going to be very reproductively viable, although, you know, nothing wrong with same-sex marriages. And then the third reason is to make sure that they, from year to year, recognize their own mate. So in addition to sex-specific and species-specific moves, they each have their own individual moves, and this allows them to recognize each other. And the funny thing is, and some of us will recognize this pattern, is that in the first 3 to 4 years of dancing, it often takes that long for them to select a mate. They're just dancing continuously, dancing all the time. And then once they've selected a mate, they're monogamous for life as long as both partners survive. And they come back and they dance for 10 minutes and then that's it. No more dancing. So they just sit down and get down to business. So that's how that works. They're long-lived. So this is wisdom. And I should have updated my PowerPoint here, but was banded as an adult in 1956. And so it was at least 62 years old in 2013. And she, it's a female, has come back now again every year since. So this year, I guess she'd be about 69 years old. And that's a record for known age longevity for a bird in the wild. Now, the reason we know that was banded was when Chan Robbins originally went out there and banded these things, he banded them with these flimsy aluminum bands. And so there were several efforts throughout Wisdom's life where they had to replace the aluminum bands with stainless steel bands and then with better bands, because the original aluminum bands would usually wear down and fall off within about 10 years. So by luck, she's gotten rebanded 4 or 5 times and now has this red band on. But there's probably, I'm guessing there's other albatross there that are just as old, if not a lot older. And if you go back, if there's anyone out there that happens to be 14 years older than Wisdom, they were there for the Battle of Midway. So that's kind of cool to think that maybe some of those very old birds that are still breeding out there had witnessed the Battle of Midway in 1942. By March, this is what the chicks look like. And one of the important aspects to our question is that when they become this age, the chicks are on their own, they're independent, the weather's great, they don't need attendance, and critically, there's no avian predators on these atolls. There's no foxes or raccoons or wolves or mammals or anything that will eat the chick. So even at this tender age, both adults can go out to start feeding their chicks. So they leave them alone. Now, it looks like this photo has 2 birds in 1 nest, but they only lay 1 egg per year, only 1 chick. But once they get to this age, the chicks wander around and, find their buddies and maybe get under bushes when it gets hot and sunny. And then when the adults come in, they call, and the chick recognizes the call and comes running up, and then the chick calls, and the adult recognizes that too to ensure that they're feeding the right chick. So by summer, May or June, this is about what they look like about to fledge. And so the whole breeding season for these is long. They come in early November. They do their courtship for about 2 weeks. They lay their eggs mostly in late November, December. So imagine Midway right now, it's going crazy. There's all the birds have just arrived and they're dancing, and it's a huge difference from what it was a month ago. Then they lay their eggs. The incubation period's 50 or 60 days. So the adults take turns incubating, and each shift is usually about 2 weeks. So each parent will sit on its egg for about 2 weeks without eating and only being able to drink water if it rains, and then they switch off. And then once the chicks hatch, and get to be that age, which was about March, they are both able to go out and start getting food for the chicks. And we'll talk about that here in a sec. So the whole breeding season is November, and then the last chicks are fledging in late July and August. So there's only 2 months, September and October, where there's no albatross out there. And I've been out on those islands a lot in those months. And what's incredible to me is you don't see one single albatross. There's not one single albatross anywhere in the area, flying off the island or landing or flying over it. They're so hardwired and seasonal to not be there during those 2 months. And overall, when you count non-breeders and pre-breeders and all this other stuff, there's probably like 1.2 million albatross breeding, visiting Midway during the breeding season. And not one of them screws up, and comes in September and October. So I find that a pretty incredible thing about albatross. Now, it sounds pretty idyllic, Midway, nice weather, no predators. But albatross, like all birds, have their issues. And one of them in the 90s was longline fishing. Now, maybe some of you might think this is a black-footed albatross, but it's not. It's the third species of albatross that occurs in the North Pacific, the short-tailed albatross. And this is a juvenile bird. And the way you identify a short-tailed albatross is by that giant pink bill, whereas the blackfoots, here, I'll go back real quick. The blackfoot, you don't really see it there, but the blackfoots have a black bill like this, and black feet, by the way. And then the short-tails have this large pink bill and pink feet. And this is a juvenile, only a 1-year-old. And I'll show you some photos of adults. But the point here is that in the 90s, the longline fishery would string out these lines with fish on the hooks, and the birds would grab the fish. And this turns out to be kind of a staged photo, but it basically represents what would happen. The bird gets hooked and dragged down and drowns. So short-tailed albatross has been a critically endangered species. It was thought to be extinct in the 1930s due to excessive hunting of them for their feathers to make down pillows by mostly Asian people. But then the Japanese went out to the island of Torishima to set up a weather station in 1953 and found a small colony of these birds. And the way they survived is that it takes them like 10 to 12 years before they even return to the breeding grounds to breed. So those pre-breeders who were out around the ocean when the last of the feather hunters went through were the ones that eventually survived and came back and restarted the colony. So they're doing really well. There's probably about 3,000 or 4,000 of them now. So they're in pretty good shape. But what we did here was a lot of conservation groups really got on the ball here and got some regulations in place to require the longline fishery industry to put a tube down and put the longline through a tube so that it goes down about 10 feet. And then it sinks from there. So there wasn't any more chance for the albatross to grab the hooks and go down. So here's what an adult short-tailed looks like. And over the years, there's been adults visiting Midway. And when I was out there, there were 2 adults on Sand Island, a male and a female. And they were located about, 1,000 meters apart. And they're pretty site faithful. So they always went back to their same sites and they never found each other. So I was there when the refuge manager got special permission from whoever he needed to for endangered species and picked up the male, took it over to the female and dropped it in her territory. And they started dancing like crazy, almost like too crazy. And they danced so hard and crazy that I think it was too much for them. They overheated or something, and the male went running back to its territory, and that was that. They never ended up establishing a pair bond. So the next thing they tried was decoys. And this bird in the middle is an adult short-tailed albatross. This is what they look like with this. They're called the golden goonie sometimes because of this nice golden head pattern and mostly white and dark. And what about this guy and this one? If you look closely, those aren't real. They're the decoys, of course. So they put these out, and then they also piped in sound of the short-tailed albatross breeding, and lo and behold, 2 of them showed up. This is this bird, the adult. And by the way, it takes them somewhere between 11 and 17 years to become fully adult. And here's the second bird here that's only partially reached adult plumage. So that's was a pair, and then they ended up breeding. Well, they laid an egg. I think it was 2010. Right, it was the fall of 2010, and then during March of that next year, we had this happen, the Fukushima earthquake and tidal wave, and that actually ended up, the tidal wave that came through Midway ended up covering, a lot of the island, and the short-tailed nest was over here on Eastern, the decoy area, and so it got washed by the tidal wave, and it was kind of a disaster for the chicks. A lot of them survived the wash, but then most of them, or many of them at least, weren't able to figure out how to get back to their place where the adults would find them. Some of them did, but there was a pretty high mortality of chicks after the Fukushima tsunami that went across Midway. But by this time, the short-tailed albatross was bigger. And so you can see the tsunami washed here, and here's one decoy here, and here's a couple of them that have been thrown up into the bushes. So this chick was able to survive, and the refuge manager or the biologist out there at the time, they weren't allowed to touch the endangered species without an elaborate permit, and they were kind of worried. It got washed maybe a couple hundred meters from the nesting site, and so it was worried that it needed to get back. So maybe I shouldn't be talking about this, but the biologist found a boogie board with a rope and kind of coaxed it to walk onto the boogie board, and then he boogie boarded it back to its natal territory where the adults were able to find it, and all was well. And this became the first fledgling short-tailed albatross for Hawaii or North America. So here it is this is a black-footed albatross chick. They're hard to tell apart, but the black-footeds are kind of more frosty on the head than the Laysan chicks, and also have a thicker, blacker bill. So another problem that albatross and birds face on these northwestern Hawaiian islands is a lot of debris. And we've all heard about the garbage patch now that's located out in the Pacific. And what happens with the albatross is that they pick up these plastic items, the adults do, and they're often covered with barnacles or some other zooplankton or animal life in the ocean. And so they think it's food, and they come back and feed their chicks. And the plastic doesn't kill them outright. However, it displaces water that's in their guts and stomachs, and so it causes them to dehydrate and die. So that's a problem with the plastic going on now. So on Midway, when we were there, we had a big campaign to clean up the plastic, at least on the beaches. But the plastic that they're ingesting isn't the same stuff. Now we did a lot of picking up of the nets, because there's also the endangered Hawaiian monk seal that breeds there, and it would get actually caught in these nets. So it was real important to pick these up. And so we do big beach cleanups, haul it all over. This is the big dock where it'd go onto a ship and be shipped off to get incinerated. So that's how we were cleaning up the beach of plastic there. And this is again, the Fukushima earthquake caused a lot of debris to come into Japan, and then this was how it floated across the Pacific to what was now the garbage patch, which is, I think, more down here. But this just shows how much plastic is in the ocean. And turns out the culprit, you know, a lot of us think that it's those dang fishermen throwing their cigarette lighters off the boats all the time, but turns out that a large majority, way more, you know, a high proportion of the plastic comes from river situations on the mainlands where there'll be a flood or a big rain and it gets washed out through rivers. So, you know, whatever we can do to get people to stop recycle, you know, that's the best thing, just recycle and try to get less debris in the ocean. So back to our question, how have these evolved, black-footed and lace-end albatross, to share Midway and be so similar but not outcompete each other? This is how they feed. They come back in with a belly full of fish, and actually the fish, the adults are able to create this concentrated oil in their stomachs, which they're then able to feed the chicks, and it's really rich. And if you've ever banded an albatross, we did a lot of banding, and you get that oil on your hands. It's kind of that stuff that no matter how long you wash your hands, you still smell it on your hands for like a month. It's that thick and horrible. But anyway, they feed that. It's really nutrient rich, of course, for the chicks. So that's one of the main ways they get to feed their chicks. And so the thought was they probably feed different things, and the food resources from early studies is a little bit different. The lace-ends tend to eat more flying fish eggs and things like that, while the black-footeds are a little bit more generalist, but there's quite a bit of overlap in what they feed their chicks as well. Both do squid, both do, I'm sorry, the lace-ends do mostly squid. And so for a while it was thought that lace-ends may be fed nocturnally and black-footeds diurnally, but that turned out to not pan out. So to find out where they go to feed, this is the big thing, you know, now with bird research, is to put these tracking devices on it. This is one of the very early tracking devices that we put on the albatross out there. And it's basically a backpack, and it records light level, and it records light for just the dawn and sunrise and sunset times, basically. And from that, you can generally gather where a bird is on Earth. And so, but you have to retrieve these things off of the albatross when they get back. So it was a little bit cumbersome. You'd put them on, you'd have to wait forever. You know, when you're waiting that long, a lot of them would malfunction. So it wasn't that good. But then starting in the early OOs, the albatross, we were able to fit these transmitters onto the backs of albatross and actually tape them on like this. And these are much better because they send the signal to satellites on the exact GPS location of the bird, and you can just sit at your computer and every day turn it on and see where it is. So this is a much better way to be able to track birds, and we'll talk about that a little bit more later in the program here. But so here's a black-footed albatross actually photographed off Monterey with one of these antennas, and we were able to let the researchers know, and they say, oh yeah, that bird, yep, he's right there, right where you saw him. So kind of ground truthing it all the way it worked. So let's see, I'm not sure why these red asterisks are here. So the first tracking device we put on Tern Island, which is about halfway out. Oh, here's Midway. That's what that is. It's halfway out to Midway. Was we put one of these on, or not me, it was actually David Wake of Duke University, put one on, or David Anderson, I'm sorry, put one on February 5th, and it went up, and in 2 weeks came back to Tern Island. So this was the adult. So that was kind of interesting. It was a 2-week trip, and that was in line with how long they, you know, shifted for incubation. And here's where the surprise came. On February 25th, so the bird incubated a little bit, the chick's still growing, but then on the 25th, this bird, and I forget if it was a male or female, took off and went all the way to California and back over a month-long period. And it's got a chick here on Turn Island. So this bird, it turns out, over a month goes all the way to California to get food for its chick here. And then it stayed on Midway for 2 days, turned around and went on another trip to California for a month and back to Turn Island. So this was the big, the big news here is that, wow, each adult, and they kind of knew that each adult could be gone for a long period of time, but we had no idea they were going all the way to California. And actually one of these birds was sighted from land, like from Monterey Bay Aquarium, and sure enough got there. And then another one did 4 of these trips in 1 year to feed its chick. And they calculated the distance traveled was the equivalent of going once around the world to feed its chick during one breeding season. So it's about a 6,922 mile round trip to the Cordell Bank National Marine Sanctuary off of Sonoma County, where a lot of Blackfoots go to breed. Now, why would they do this? Okay, so we're lucky here off our coast to be living next to one of 4 eastern boundary current systems. And what they are these systems that are on the eastern edges of oceans, of large oceans, so the western coasts. And because of the Coriolis effect and things like that, and we're in the northern hemisphere here, the currents go clockwise around the Pacific. So we get this colder, nutrient-rich water coming down off our coast every summer, and that's what fuels our productive ecosystem here. And the same thing happens down off of Peru and Chile. Only in the southern hemisphere, the currents are going counterclockwise, so you get the same effect. You get polar water coming up along these coasts, and the colder the water is, the more nutrients are in it, and the more phytoplankton blooms and the more zooplankton and so on. So you get these incredible marine ecosystems with tons of birds and animals and stuff in these systems like here. Another thing off our coast here is what's called upwelling. And that's where these northwest winds, like we had last Sunday, come zipping down along the coast and actually shear off the surface water. So the surface water goes outward, and then that drags up colder water from the depths, which are also high in nutrients. So the combination of the California current coming down plus upwelling events causes it to be very productive here. So the albatross, by contrast, the big Central Pacific gyre has got warmer water. It doesn't mix around as much, and it's very unproductive. A lot of oceanographers refer to it as a marine desert because there's so little life on a per cubic yard of water basis than there is along our coast. That it's just that all of the whales and animals and seals and sea lions and all that we see off our coasts are here because of this system. But once you get a couple 100 miles off the coast, everything drops off. So that's one of the reasons why the albatross come all the way to California to get the food, because it's so much richer. And then here's another thing that's really cool is that if you've never been out and seen an albatross, say from a boat, you really should go on a Monterey Bay trip. There's some of those trips are 6 hours. They just go out and you get into this deep water very quickly, and you can see these trips, or go on Al Jaramillo's trips off of, I think he's doing a couple down there, but he does mostly off San Mateo and Bay Area. But anyway, just go out and watch one, and they just are so amazing, and they're gliding around, and they really use the winds to their advantage. And what they've realized is that the winds are such during that critical period in the March, April, May, June in the spring, when they're feeding their chicks, that typically you've got these northwest winds and east that come across the Pacific, and they've learned to be able to ride those winds all the way between Midway and California without hardly even taking a flap. So they can just, if you watch an albatross, they just rock back and forth and let the winds do the rest. And it's actually been learned recently that they sleep. This is when they sleep. So they're busy breeding, they're busy dancing, they're busy incubating, they're busy feeding chick, blah, blah, blah. Then they have to go get food. But during those 4 days it takes them to cross, they actually are getting their shut-eye in. So they're asleep. They can sleep on the wing, and they just put themselves on autopilot and go. So that's one of the reasons why they're able to do this, that they don't expend a lot of energy themselves doing it. So this is a graphic I found recently that shows how they can go, no matter what the wind direction is. I don't quite get it, but no matter what the wind direction is, they're able to use it like a sailor is and get between point A and point B. So meanwhile, the chick's sitting back here. And so if you do the math, it's only getting fed on average once every 15 days, half a month. And if the parents aren't in sync, then it might be sitting there for as long as a month without getting food. But this is the way a lot of marine animals are built. It's boom or bust. You fill up, they come back, they fill this chick up with all the food and this viscous oil, and the chick's then able to sit around for a month without needing to feed again, and it continues to develop and grow. And then as an adult, you get the same thing with whales and seals and elephant seals and everything. They go and eat and get really fat during a certain period. And then they're often able to, for instance, the elephant seals go for, the whole breeding season. The males come back in November, December, and don't leave till March, and they're not eating that whole time. They're just at the colony. So and whales do the same thing. So it's a real gain a bunch of fat, gain a bunch of weight, and then you're able to go for long periods without food. And that reflects the fact that the food distribution in the Pacific in general is really patchy. And and because of the cycles in the weather, El Niños and La Niñas, it may be pretty sparse for long periods of time as well. So this is a mechanism that allows them to survive that. So back to our question, how come? What's the difference? Well, when they put a lot of these tracks on, here's Midway down here, yellow is Laysan, green is black-footed, red is short-tailed. And they find that the three species pretty much go to different parts of the ocean to feed for the most part. You see a lot of blackfoots way up in the Bering Sea along the shelf ice. A lot of them come to the west coast like we showed, whereas the Laysans tend to favor this big area around the Aleutian Chain. And it probably has to do with a very specific food resources, squid, in the case of the Laysan, maybe that spawn here during certain times of year. And for some reason, the Laysans are just a little bit better at getting that food resource, whereas the Blackfoots are larger. And maybe it's actually that the Blackfoots dominate the feeding areas that are more productive, and so exclude the Laysans from this area. And we really don't have enough data on short-tails to say much, but probably something on a similar vein distinguishes themselves. And so it's a two-part answer, really. The first is that this is the closest place to all these feeding grounds where you've got a predator-free island that's warm enough where the chicks can be left alone at the age they're left alone. And the second thing is then they're able to go these very long distances to feed. So those two things, a predator-free island here, all of the islands, of course, around here have predators on them, and it being warm enough is what caused this whole situation to evolve, and for the two species to evolve and breed together on some of these islands in Hawaii. So this is the point where I shift gears, and David, if you wanted to, or Judy, whichever one you want, if you wanted to rattle off some questions, I'll be glad to, about Hawaii part. It might be a good time to do that and take a break and, do what you need to do.
Okay, this is Dave. If anybody else has any questions that you'd like to ask regarding the albatross and what Peter's just talked about, go ahead and type them into chat. The first question we had, Peter, is do you know at all how many mates that Wisdom has had?
No, I don't think they do. That's a good question. She wasn't even really found until, I'm going to say, the late 00s, because they were entering all these bands into computer. And it took a long time for that to happen. And then they had to match all the bands that were changed. And so they didn't even really know about Wisdom until she was already like 45 years old. So there's no way they knew who she bred with before that. And then second of all, I think most of her mates have been unbanded. So there wasn't really a good way to do it. Now, maybe they've gone and banded the male mate since. I mean, that would be a good question. But I think, unfortunately, the answer to that is no, we don't know how many different husbands she had along the way.
Okay. And what about, how can you explain how the decoys work?
Yeah, they're just a visual aid. So the birds are flying around and they see those decoys sitting there, and they're bigger and they're whiter, and you know their color pattern is not Laysan or Blackfoot. So that's the first idea, is that they'll see those. But I think the real, and then, or maybe it's a 1-2 punch. The real thing that caused them to actually go there is the piping in of the sound. So they went to Torishima and recorded basically the caterwauling of a short-tailed albatross colony. And really it is a caterwaul when you're there. The Laysans, you know, they're just making all this racket all night long, and you got to just kind of get used to it, or you're never going to get to sleep out there. But it's just all this mooing and clapping, bill clapping, and whinnying and whistling and just all this stuff. Well, short-tail, I'm sure, has its own set of sounds. So I'll bet you the piping in that sound is what was the main thing that got them to the decoy area. And then you just wait for two birds of the right opposite sex to show up, and then they're on their own, and you know that's what happened.
Yeah. Is Midway and the nesting sites, is it threatened by sea level rise now?
Yeah, there's some worry about that now. There's some talk of putting armoring the coast, you know, putting up walls and stuff. Now, if sea level rise occurs slowly enough, then the coral will be able to keep up with it, just like it has over the years. So I don't know the latest on that question specifically. I'm sure there's geologists and oceanographers who are asking it, and but there is that worry. And you know, of course, there's some island nations elsewhere in the Pacific, the Marshall Islands and Nauru, and places that are even more low-lying than Midway. I think the highest point on Midway is a big old sand dune that's 44 feet high. So it's going to be a while before that gets subsumed. But you know, there are other low-lying atolls that are already, I think, becoming uninhabitable.
Okay. And how long do the trackers last? Are the trackers from 1998 still operational?
No, we don't. You know, you can get those back, but the battery life is the main thing. And for those trackers of that size, battery life can be 6 months, maybe up to a year. But you only get that amount of data off of each device, at least at this point. Now, I'm sure the technology for trackers is really increasing, you know, in leaps and bounds right now. They're even talking about putting trackers on insects and things. So potentially, and with, you know, battery shelf life technology also improving, we might be able to get something like that. With the white shark, actually, which I'll talk about next, they do make trackers that you bolt onto the fins that are able to go for 5 years, battery life of 5 years.
Is there any record of or possibility of Laysan albatrosses nesting in the Channel Islands?
Yeah, what's happened there? They're nesting on Guadalupe, which is 200 miles south of the border and 200 miles off the coast of Baja. And they've also started nesting in some of the other islands off of Baja, pretty far off. So that's you know, that's getting there. And then I guess with global warming, you might think they could start breeding off of California, but the Channel Islands are in pretty cold water. So there's a big water temperature difference between here, and the Channel Islands is all part of this California current system, and the Santa Barbara Channel is really deep and really cold as well. So that might create it being too cold for them to breed. And then the other thing you got to think about is the island fox, and I'm not sure if
Oh,
there's
yeah.
any predators there as well. So that would be the two things that might prevent that.
And how are the adult birds captured for banding?
You can just grab them usually when they're incubating. We do it at night. Most of the banding occurs with the chicks, so that's a lot easier. But when you have a known age bird, and you want to band its mate, you just take a big old fishing net. What you can do is go take the egg out of the nest and replace it with a dummy wooden egg, so that the egg doesn't get busted in the process. And then at night, just go up with a big old hoop net, and just you can go up. They're really tame, so you can walk right up to them. They haven't evolved. Humans haven't been on those islands forever. So, and they're an ancient bird species. So over the millions of years that they've been breeding on Midway, they've never had to worry about humans. And then luckily, most of the humans that end up going there don't do anything. So they're pretty tame.
How do parents recognize their chicks when they come back to feed them?
By sound mostly. So the chick will wander around, and the nest might be out in the middle of a hot field. So it'll go under a bush nearby, or a tree, and sit in the shade. And then the adult comes back, and it has this one call that's kind of a laugh. It's kind of like like that. And that's the call that it gives a lot when the chick's in the nest, and it's the one that the chick will recognize and run out. And then the chick has its little peeps and squeals, and the adult recognizes that in return.
And it kind of looks like a lawn where the chicks were hanging out. What's the vegetation like in these open areas?
Yeah, it is a lawn. It's a naval lawn. I don't know what kind of grass. None of it's native. There's the native vegetation out there is in the sand dunes. Historically, it's all sand, and so you have, I think, probably maybe 20 species of native plants. A lot of them low-lying. The two species, the scaevola, which is called now paca in Hawaii, but it's a pantropical species, is common there. It's a low bush. And then this other one, a heliotrope or Tournefortia tree, is the other thing. Those are the two kind of more tree-like species that are there native. But then you've got ironwoods, that kind of look like our cypress, and things, all kinds of garden variety plants, and some really bad invasive plants. Verbena, verbena, was it verbena? No, that's the one here. But there's some plants that have become a problem as well. So people have been trying to eradicate them.
Okay, I think that's it for the questions this time, Peter. So I'll let you go ahead.
Good. Let's come home. Let's come closer to home here. So this is the Farallons, and this was my life for 24 years. I first got out there as an intern in 1980 and worked out there all the way through 2003. And it's located 27 miles from the Golden Gate Bridge, and the closest point of land, if you look back here, this is Point Reyes, and the Point Reyes Lighthouse and the Farallon Lighthouse are both exactly on the 123rd parallel, which is interesting. So directly north-south of longitude, and it's 18 miles. They're 18 miles apart. So this is the Farallons where it's located, and there's two old Victorians built there in the 1870s. This was the house we live in. This one was the one the Coast Guard maintained and stayed in, and then they're both now Fish and Wildlife. So we have excluded the television to this house, and there's no television in our house. And if people really have to go watch television, they'll go over to the Coast Guard house. And I used to go at 6:23 every evening to watch the weather and look at the weather satellite photos. And that's the only television I ever watched out there. This is our generator house. And then there's various old structures. These water tanks used to feed the system, but they've been taken down. It's one of the few places on Earth where it's been getting less crowded. So it's got a real long, interesting history, which I'm not going to go into, but there's egg wars. It started in the early 1800s with sealing. There used to be a whole lot of northern fur seals breeding here, and they got all decimated. And then the egg wars happened after the gold rush. And then there was a period of World War II where there was a population of 80 or 90 people living on the Farallons, and now it's reduced to just a skeleton crew of biologists who work for Point Blue Conservation Science, used to be Point Reyes Bird Observatory that I work for, and they're got a cooperative agreement with the U.S. Fish and Wildlife Service to maintain a presence basically here 365 days a year. And PRBO actually got here a year before it became a national wildlife refuge in 1969. So it has a similar story to Midway in that it used to be government, used to be military, then it got turned over to Coast Guard to maintain the lighthouse. And then in 1969, Coast Guard gave it over to the U.S. Fish and Wildlife Service. So it's now a national wildlife refuge. So this is another talk I give, Ecology and Conservation of the Gulf of the Farallons. And it basically goes through in more detail than I'll give now, the animals and plants and so forth and everything on the Farallons. But in a real brief recap, we have 13 species of breeding seabirds there. You guys know a lot of them. Puffin is one of our good ones, but we only have about 60 pair of those. Common murre is the most common, with about, I think, over 250,000 now, been increasing. And most of the birds are doing pretty well out there. The exception is the ashy storm petrel, which has a large population breeding on the Farallons. It's like 60% of the world population breeds there. And yet their population is declining because of burrowing owls preying on them. And the reason the burrowing owls are there is because there's introduced mice on the Farallons. And maybe some of you know the big controversial thing going on now with trying to get rid of the mice. I forget if I have a slide in here on that whole story. I might or might not. And if I don't, that's just fine, because I'm kind of sick of the whole thing talking about it. But one thing we really, really want to do is one way or another get the mice off the Farallons so that the owls do not winter on the island. And what happens is the mouse population crashes in the first rains, and then the owls are out there starving, and then the storm petrels come in, so the owls start eating the petrels. And it's resulted in a large decline of this important population for ashy storm petrels. So we have a lot of studies on the island where we ban birds, we check their nests, we determine reproductive success, we watch what food they bring in, we record fish species and everything, lengths of fish, and some of that data really helps fisheries biologists with their managing of the fish resources. We've recorded 35 species of migrant seabirds in and around the Farallons. Of course, you guys probably have this down there too, but the big, huge flocks of sooty shearwaters that show up in August, usually, to molt here off our coasts, largely, I think from the Bay Area down to around your area. And I'll actually talk about that species a little bit more. 6 species of pinnipeds have been recorded there, of which 5 breed. This is a Guadalupe fur seal. That's a more recent arrival to the area. It has the same story as the short-tailed albatross and the elephant seal actually too, where they thought it was extinct at the turn of the century, but then found small colonies of each of those 2 species breeding on Guadalupe Island. And elephant seals, California stellars, also we have harbor seals out there and northern fur seals. And then we've recorded 25 species of cetaceans around the island. So that's pretty cool. The reason it's so productive is because this graphic is exaggerated, but it kind of gets the point across that the Farallones were on the edge here. So as you go west of the Farallones, you drop off into the depths. So here's the real edge of the continental shelf. And then the water depth between the mainland and the Farallones is about, a pretty consistent 180 feet or so. And then as soon as you get to the west, it drops off. So we're real close to this cold, nutrient-rich water. And here's Cordell Bank, which does not break the surface, but it's part of the same geological ridge. And this is called Bodega Canyon, and the water actually comes swirling up Bodega Canyon too, and helps feed the whole nutrient system and the wildlife. So about a week after I first got on the island in September of 1980, I looked out and I saw something like this going on, blood and splashing, and I pointed it out to the biologist there. Oh, shark attack, that's a shark attack. So we all watched it through scopes, and this is all you really see is this going on. And it was Phil Henderson, and then he said something I'll never forget. He says, we're not sure what kind of sharks they are, but all we know is they're big, and they're probably white sharks. So that was the state of the knowledge of white sharks back in the 1980s. And so when I became a biologist there, I was out in the fall from August to December to mostly do land bird monitoring. That's our big season for that. But it's also when the white sharks occur. So I couldn't help but get kind of dragged into the whole white shark research. But it was really an exhilarating project to work on and to kind of follow through from not knowing even what species it was to doing a lot of research on them. But I always say this, like whoever named the white shark must have had one upside down because they're not white on top. They vary basically from a grayish to blackish on top. And the reason is that they're an ambush predator. And what they do is they like to cruise around above rocks around the Farallones where this coloration provides camouflage. And when a seal is up on the surface, not paying enough attention, they come up and race up and grab it like this. And then they eventually, then they wait for it to see if it'll die or not. And then make sure it's dead because they don't want to be feeding on a struggling animal. It would probably injure the shark's eyes. So once it's dead, then they come and they feed on it. So we gradually got the nerve up to get into boats and go kind of visit these feeding events. And we learned a bunch of stuff that way. One is that at each feeding event, there could be multiple sharks present, maybe up to even 15 white sharks would get attracted to one feeding event. And long after the carcass was gone, there'd be the smell of blood and oil in the water. And the sharks would see the silhouette of our boat and would think maybe that's part of the carcass. But at that point, they're not in that attack mode. So all that stuff you see on Jaws and whatnot is not what they do. They actually are in an exploratory mode at that point. So they see the silhouette of our boat and they go up and they just circle around. And so what that does is allows us to, what we had were video cameras in these housings, and we were able to videotape the sharks and the feeding. And if you look at the serration pattern on the trailing edge of the dorsal fin, each shark is unique here. So you can tell each individual shark through that pattern, also scars and marks on the body. So here's some of our data on some of our sharks, and we started numbering them all, and the first number here was the year that we first identified them. And so some of them have cut off tail fins, some of them have cut off dorsal fins, and we named them all, of course, like, half tail or half fin and cut tail. And this one, you'd think that another shark bit it, but no, if you look closely, this is a big old propeller wound on the top of this shark. So it went too close to a boat, and the spinning propeller ended up causing this scar. And so all of these scars, blunt nose here, all of these scars are, you know, allow us to be able to identify each individual, and we're able to find out that individuals return each year. One of the big findings of our research was that individual female sharks, and you can sex them by, there's claspers. The males have these claspers underneath, and so that allows you to sex them. So the females would only return to the Farallons once every other year, whereas the males, the individual males, would return every year. So we'd have females were there every year. It was just, we'd have odd year females and even year females. And so that allowed us to speculate that there was a 2-year reproductive cycle where the females would go off for 2 years to give birth to their pups before returning to the Farallons. And I think I've got a slide to talk about that a little bit more. But basically, the white shark's a real, what we call a K-selected species. It lives a long time, like the albatross, but produces very few young in comparison to other fish species. So every 2 years, I mean, well, the number of pups they're called that white sharks can bear every time, it ranges between like 4 and 11, something like that. And then the fact that they only breed once every other year, you got to cut that in half. So basically they're only producing between 2 and 6 young per year, which compared to like salmon, some of these other things that produce millions of eggs, you know, it's quite a different strategy. So we predicted that they would be long-lived based on that. And some of our research here really does indicate that, for instance, Cuttail 88, we've seen him since, we saw him, I saw him the year I left in 2003. So that's, what is that? That's, you know, that's 15 years later anyway, but he didn't change at all during that period. And so since then they've been looking at cartilage rings and things like that, and think that some of them may live to be over 100 years old. So, so part of our research was just to document the attack. These were the early years of our research, and all we did was we counted the number of attacks that we would see from the island, and there wasn't a standardized effort, but we were out every day, so it was kind of standardized. And you could see that the number of attacks between 1969 and 1982 gradually increased. But this year in 82, there was a fisherman out of Half Moon Bay that came out and killed 4 white sharks, 4 adult white sharks, and took them back. And, you know, he did all kinds of illegal things, shot a sea lion, hooked his hook with his fresh sea lion. You know, you'd never be able to kind of get away with that now, but back then there just wasn't the enforcement. There were the laws, but not the enforcement. So immediately you could see our attacks per year dropped real low. And we used this graph in the early 90s to fight for a protection bill in California to protect white sharks in California waters. And we were successful with that because the guy who fished them probably sold the jaws for $10,000 each. And then there was a black market for the fins and so on. So, you know, potentially it could have been a problem. But the white shark population is so small that even the removal of 4 around the Farallons had this effect at the time. And then we also, there's a, you know, this big cage diving industry that occurs with people wanting to go out and do this kind of thing and get into cages and see white sharks. And that was really increasing a lot. These were the number of days of operation which cage divers would come out to try to see sharks. So in the early 00s, it was really increasing. And back in there was no regulation. There was no, you know, you could throw pig. We just saw people throwing all kinds of chickens in the water and pig carcasses and blood, dumping cow blood over. And there was even an idea that electrolyte chemicals could bring in the sharks and dragging seal decoys around. And, you know, it was kind of the Wild West. So we're not opposed to the adventure tourism, as it's called, but we worked with the Marine Sanctuary program to get both a permit, a licensing and a permit process in place where they can only do certain things. They can only do minimal things to disturb the sharks. And also they have to have an educational component on board where they teach the value of the white shark to the marine ecosystem. And part of the stuff we did was I give a lot of talks to surf rider groups and surfing groups, and I always like this. They were always wanted to know. But these were recommendations I'd give to surfers to avoid getting chomped, as I called it. But I liked number 5, pay attention to spook feelings, because what turns out when you interview people, divers and surfers who had gotten attacked, or kayak people, they all kind of had a feeling right before they got attacked of kind of ominousness, like shouldn't be there. And it might be some ancient feeling, ancient sense that we have that we're not in a good place. So I surf, and I've gotten that spook feeling once in a while, and I just go in. There's no point. I'm not going to mess with it, you know. And another one we tried was we actually contacted O'Neill Wetsuit Company and tried to get them to do either checkerboard or pinstripe wetsuits, because we figured the less divers and surfers looked like a seal, the better. And this went absolutely nowhere. And it turned out the problem wasn't the idea, but the problem was that surfing is such a fashion conscious thing now that none of the surfers, I think, wanted to go out there in a checkerboarded wetsuit. It just, you know, be the Joker and the deck of cards on the beach. Here was a big event we had on October 4th, 1997, where orca came in, a group of killer whales came in and actually killed a white shark. And that was a big event. But what was even more exciting for us, this is kind of an old bad graph, but was that year, as soon as, so the black bars represent our normal activity of white shark observations from the Farallons. And then the hash bars represent 97, right up till the day that happened. And then there was just all the sharks departed the Farallons for the rest of the season. And it was really eerie. You know, we knew immediately that something was wrong when after like 3 days after that attempt, after the orca came and killed the white shark, there was just, we didn't see anything. And it was like that for the rest of the year. So our season, we had all these plans and tags and all this stuff ready to go, and the season was a complete bust. So that was really interesting. So now there's been a lot of speculation. You know, we thought, okay, can we cash in on this? What is it about an orca getting a white shark that causes all the white sharks to leave an area? So if, you know, if we were able to isolate that, maybe we could make $1 million. But what, you know, I wasn't going to do that. But the thing that we came up with was maybe the livers of white sharks are really huge and they're really pungent. And so possibly the carcass of that white shark was giving off chemical from the liver, which spelled death to the white sharks. And that might have been the thing that caused them all to leave right after that. And then the same thing happened in oh, well, maybe I'm not going to tell that story. We'll get to that next slide in a sec. But anyway, the same thing happened in 2000, and we did have a tag on a shark that year. Maybe I have a slide on that coming up. But and we were able to see that within an hour of the attack, that shark went out over the edge of the continental shelf and didn't stop till it got to Hawaii. So anyway, now this image in the, I think it was early 00s, late 90s, you know, this was created with Photoshop. This shark was taken by a friend of mine who's in South Africa. And of course, here's the Golden Gate Bridge. So, but these were the real early days of Photoshop before people realized that you could do this good of a job with it. So every few months I'd get this photo and say, is this real, you know? And so people were still under the, you know, the Jaws, the influence of Jaws, that this kind of thing can happen. The white shark can go up and grab the helicopter and bring it down. I got so tired of answering that program. They go, yeah, it's real. After eating the guy, it went into the helicopter, drove up to the bridge and started throwing cars off the bridge. And even then, people would go, really? So that's how much it is. But I think one of the big things that we were able to do with this white shark research is really change people's attitudes about these animals, because they're keystone. They're key to the marine ecosystem there. And what I would say is that if you got rid of the white sharks, the pinniped population would go out of control. The pinnipeds eat the same fish that we like to eat, salmon and halibut. And so our salmon and halibut would go down. And with using that argument as a rationale, we got all of the fishing groups and everything behind us on that bill to protect them off California, which was really, really satisfying. And even the surfers and the kayakers were in favor of that bill. And the surfer write-up on it, comments on it, was that when we go out into the ecosystem there, we're part of the food chain, and we know that, and we like that. So that was their attitude about it, which I thought, oh, that's cool. And then later, the head of the surf rider told me that, well, really, what it was that the white shark scares a lot of surfers from the California coast, so it means there's less crowds. So that was the real reason they were behind the bill. All right, so remember the tags on the albatross. Well, this is the equivalent of the white shark, and it's called a archival pop-off tag. And because the tags can't transmit through water, what you do is you put them on, they collect data, you program them to release and pop to the surface after a given amount of time, and then they send the data back by satellite. So that's the only way, or no, that's not the only way, but that's the way we started out trying to study the white shark and their movement patterns. So this is a female. The females are bigger than males there, and these scars on the sides of the females are mating scars. And nobody's ever seen white sharks mate, but other sharks, the males go over the back of the female and bite them on the sides during copulation. So that's what these are. And this little thing here, that's this archival pop-up tag, which is about 8 inches long. So you get a kind of feel for how big some of these white sharks are. This one was white slash. She was one of our bigger ones, like 18 or 19 feet in length. And we have a couple out there that probably are over 20 feet. So the first tag we just put on for 2 weeks, and it popped off and sent the data back. We just wanted to see if they'd work or not. And sure enough, right away we got data. And so what the tags record are, again, the light levels. And so you're able to, with this curve, so this is 24 hours, and it's night, and then dawn, and then the day, and dusk, and then night. So with these exact curves, you can figure out the time of day and how long the day is. And from those two metrics, you can pretty much figure out where you are on Earth. And that's how these geolite tags work. But immediately, so this one is a depth recorder on the shark. So you can see immediately that, we didn't know if they were nocturnal, diurnal, all day long, but you can see clearly that its activity patterns increase a lot during the day and then decrease a lot at night. So they don't feed at night. That was one of our questions. Probably their eyesight is not good enough to be able to hunt at night. So already, right off the bat, where that first scene of Jaws where the shark gets the woman at night, that's just not right. So already we were starting to debunk Jaws. So we put 2 test tags on, and they both popped up near the Farallons. That's fine. Then the third one popped up out here, and we were surprised because we thought white sharks were going to be part of this migration that occurs up and down the coast with seals and sea lions and anchovies and pelicans. And there's a lot of and there's a whole marine ecosystem that goes up and down the coast, comes up here in fall, and then goes down here in spring. And we thought white shark was part of that, but then this seemed a little far out. And then the number 4 popped up even farther out. And then number 5 popped out here. between Kaho'olawe and Maui in the Maui Channel. And so this was what got us a paper in Nature. And we were able to, our first thought was, okay, let's contact the Hawaii Tourist Bureau and ask them how much they would fund our research if we just didn't publish this. But we went ahead and we're good scientists and published it. So that was a big surprise. So it turned out that white sharks have a large east-west component to their migration. And along with the albatross and several other animals, that's kind of a story we've been learning with these tags, is that there's a lot more east-west than we had thought before. So zink, 5,674 mile round trip that these sharks take. Now this is Tipfin. He was a male that we knew, and then he did this, and then we got another tag in him, and he was actually the one that went to Hawaii. So, or maybe it's the other way around. But anyway, what we've found is that the males tend to do this, go out to the spot here. Yeah, this is his trip to Hawaii and back. So they go out to this spot, and a lot of sharks go here, and then he went to Hawaii and then back to the Farallones in 1 year. Well, the females, it turns out, also come here, but then we don't have tags on them that are long enough to know what they do in the 2 years since that. We only got 6-month tags. So it turns out there's only records of pupping white sharks in the warmer waters of the Western Pacific Ocean in here. And there's quite a few. There's Japanese netting operations have probably captured 20 or 30 pregnant female white sharks or pupping white sharks in this area, whereas there's not a single record of a pupping white shark here. Part of it's the water's probably too cold. So if they are here, they probably have to go down south. But we started coming up with the theory that some of the females, at least from the Farallones, probably go all the way to the other side of the Pacific to give birth to their pups, and then they come back, and this is a 2-year cycle. So here's a more recent paper that shows all of the tags, and again, if you looked at this from the side, this would be a mountain of yellow, and I'm not sure what the red is, but of dots for this area. And originally, the shark researchers, we were working with the Hopkins Marine Lab at Stanford to do this work, and they originally dubbed this the White Shark Cafe. However, it's in the middle of nowhere. There's no seamounts here. There's no pinnipeds or mammals to feed on, or at least not in the abundance that they need. They really can't go deep enough to get to the ocean floor here. So it doesn't seem like they're coming here to eat. So our theory now, and I want to keep sticking to it, I'm battling with the folks at Hopkins over this, is that they come here to mate. So this is the mating ground. The males come here and the females. The males go back to the Farallones. They might go to Hawaii first. And then the females go off and breed. And actually, there are a couple females. Like, here's Midway. So a couple females have gone all the way out the Northwest Hawaiian island chain. But unfortunately, we don't have the records of them to see where all they go within the entire 2 years of their being away from the Farallones. So I would rather call this the White Shark Swingers Club, maybe. White sharks are a part of a really ancient lineage of sharks that have been around the ocean for like 400 million years, longer than trees have been in existence. So I kind of wonder if this area was an ancestral mating ground that used to be near a coast, but then as the plates have moved around, potentially this area became farther out, but they maintained the adaptation to return to this area, even though it's no longer near a coast. And as far as we can tell right now, it's simply in the middle of nowhere. So back to this story, I thought I might get back to this. November 19th, 2000, we had another orca attack, and here's that tracking I was telling you about, Tipfin. So here he is around the Farallons in the shallow water. And then November 19th, within an hour of when that second killer whale white shark attack occurs, boom, he goes west, he goes down to 500 meters deep, and then he stays at this depth for the rest of the fall, winter, and heads off to Hawaii. So that was Tip Finn's record, and again shows that for whatever the causal mechanism is, when a orca hits a white shark, it causes all the white sharks to disappear. So now recently they've published another paper on this whole situation and found out they had tags on the sharks and then looked for killer whales around the Farallons, and turns out they do scatter from the island when the whales are just present. It's not just when one's killed necessarily. So maybe the mechanism's something else. It's hard to know, but it turned out a lot of the sharks actually just come to our coast at that point, as well as going off into the depths, came back to Año Nuevo Island and where there's other seal colonies. So we'll talk about a couple more species here before we wrap up. The funding for this tagging of archival tags came from this species, bluefin tuna. And the original question that the folks at Stanford had was, where do these bluefin tuna spawn? Because we need to know that so we can potentially protect those areas and allow this fish to spawn that's so commercially valuable. So it turns out through these tags that they found out that the spawning grounds was largely up here in the Bering Sea in this area. And then what happens, they went up here and put tags on the young fish that were just born. And in their first year, these young fish come all the way down to this area off of Baja, and then it takes them a few years to gradually work their way back up to be, and by then they're old enough to be spawning and breeding themselves. So really this whole life cycle of the bluefin tuna was learned through these pop-up tags. And then the big, end goal here is to be able to make this into say an international marine protected area, so you don't have fishermen and all racing up here and grabbing the bluefin tuna that are spawning, because that's not going to be good for their populations. So there's a website here you can go to if you want tagging of Pacific pelagics or top, and you can track individual animals. You can see all the species, salmon sharks, pinnipeds, elephant seals. They've even got tags on Humboldt squid and a lot of birds and so on. So there's all kinds of cool stuff. And then the other thing about these tags is that they're not just recording the location of the animal, but they're also recording all of this data on the ocean itself, where the animals are going or what water temperatures and salinities and oxygen levels and all this kind of stuff that they prefer being. And so that really helps us understand these animals and identify what we call hot spots in the Pacific to be able to conserve them and understand them. So as I mentioned, we're starting to put tags on smaller and smaller species. Here's a tag, and now we've got little solar panels on them as well, so that their battery life can be longer. This is a bar-tailed godwit, and the story of these guys was learned through these tags, that they'll make a non-stop flight. They breed up here in Alaska. They make a non-stop flight all the way to New Zealand in the fall. And so that's pretty incredible for a bird. I don't know what the round trip is there. And then in the spring, they do this hopscotch on the way north, and there's a couple areas that are very important to them. And so they've been able to identify them here. The Yellow Sea here off China is really important. And so that's spurred on a lot of conservation efforts to try to, conserve these areas and stop hunting in them and so on. And the big story here was this one bird that got tagged. I think it was a female. She came down to about here, and maybe it was weather, I don't know, but for whatever reason, she turned around and went back up toward the Yellow Sea, and then turned around again and then came back and finally made it to New Zealand. And she was flying for 9 straight days. So that's how adapted these birds are to be able to make these migrations. And some work on the breeding grounds indicates that they fatten up so much before leaving that actually some of their internal organs get subsumed with fat. And that's how they're able to stay aloft and use up all that energy flying. And I'm sure they've figured out altitudes and winds and all this other stuff like the albatross to be able to take a route that's the least amount of effort. So we always used to hear as kids that the Arctic tern was the #1 bird for migration in the world. It would go all the way from the Arctic to the Antarctic every year, and it was the champion flyer. But these tags have made us realize that this species beats out the Arctic tern. And what happens with this guy, sooty shearwater, is that instead of like the Arctic tern just goes boom, 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 they breed, say, in New Zealand. They go over to Chile to take advantage of the spring here, which is this eastern boundary current system. Then they do a big figure 8 and go up to this area to feed in late spring, Bering Sea. Then they come to California where they molt and take advantage of our eastern boundary current system. And then they go back to New Zealand. So some of these birds do a giant figure 8 in the Pacific from their breeding site to return. And I'm sure they've got it probably on the web, internet somewhere, but one of these birds holds the record for, distance flying in 1 year, I'm sure. And as I mentioned, we're getting tags now on smaller and smaller birds to be able to figure out where they go to not only to spend the winter, but some of these birds we're finding out they leave the breeding site, they go somewhere to molt, and then they continue. So they as well will have like a 3-part migration sometimes. So we're learning some of the migration routes of smaller birds. Here's a study our group did on black-headed grosbeaks and how they go from the breeding sites to the molting grounds here, connected with the monsoonal period of time here in August, and then they go down to the wintering grounds here. So again, it's a 3-step migration process. And eventually I'm looking forward to when they get transmitters on hummingbirds. And so I can sit at my computer, put one on in my feeder and watch it buzz around the neighborhood. I can't wait for that. That'll be fun. And then, as I mentioned, insects are on the horizon, I guess, for these little things. So speaking of insects, there are some other great flights that have occurred with insects as well in the Pacific. And this is called the Kamehameha butterfly in Hawaii. And it looks like it's a Vanessa. It looks like one of our painted ladies. But at some point in the history of evolution, these guys not only got out all the way to Hawaii, but started breeding and formed their own species there. So that's kind of testament to even these butterflies can fly thousands of miles sometimes. And I have a story where in the early 80s, oops, I didn't mean to do that. In the early 80s, I spent some fall periods out on Midway Atoll, and it's next to Midway. It's actually the last one. It's about 60 miles west of Midway. And while I was there and the date was September 29th, 1983, all of a sudden there were thousands of these dragonflies on Curie. And there's no water, was no real water. They weren't breeding there. They'd all migrated to Curie, thousands of these things, these globe skimmers. And so wrote a little paper about it here in the proceedings of this journal. And then a little bit later, just more recently, I was just watching a TED thing, and this guy, Charles Anderson, discovered that this same species crosses oceans. And he was working on the Maldive Islands, or Male, on this island. And he found out that these globe skimmers did the same thing. They were migrating from India to Africa across this large expanse of ocean. And some of them are going down to Madagascar. And so he would see these big migrations here. And so he documented that. And then it turns out that these things do like a 4-step generational breeding system, like monarch butterflies, where they breed here one year and then they go across to Africa and breed here. The next generation breeds here, and then somehow the following generation knows to go up here to breed, and then the next generation knows to go back to India. So how that works is pretty amazing. But I guess monarch butterflies do something similar. Another interesting part of his talk was that he found that birds, such as this is a hobby, it's a species of falcon, and other birds like rollers and so forth would actually follow the dragonflies, and these birds are able to catch them and eat on the wing. So, potentially this is how the hobbies fly from India to Africa, as they follow the great dragonfly migration and have a continual food source as they're flying along. So that's pretty cool. So also on the same day in 1983, I had 12 to 15 olive-back pipits show up on Curie, and so that was kind of funny. And so the closest point of land, continental land, is 2,400 miles here. So this flock of pipits somehow flew all the way to Curie from somewhere, Kamchatka, and got to Curie, and they all were fine. They all landed and they started hopping all around and eating. So that was kind of interesting. And so that started a discussion. We get, some of you birders out there know, we get some of these Asian birds here in California. Right now, the big talk's about white wagtails, because relative to the eastern yellow wagtail here, there's white wagtails. It's a big year for white wagtails in California. There's one in San Mateo County yesterday or the day before, and then before that one in Santa Cruz. There's been one in Mendocino, and I think a whole bunch down in your area in Southern California. So, get out on your beaches and look for white wagtails, because there's a bunch of them out there now. Well, how are they getting here? So, there's various theories where these Asian birds might be following the coast. But one interesting thing is that the farther south you get, it seems like the more common they are relative to the amount of effort. So a lot of them get to Baja for some reason. There's a fair amount in California, but there's very few up here along the coast here. And part of it, of course, is that there's hardly any birders up in these areas. But it seems like they're more common the farther south you get. So it suggests some sort of transoceanic route that they might be taking. Now, if the pipits can get from here to Curie, it seems like maybe they can get from here to California as well, or they might stop in the Aleutian Islands to get here. So that's kind of a big question we have, why Baja actually gets a lot of Asian vagrants, more so per effort of birding than California. So why would that be? All right, one more story here, and this is the leatherback turtle. And we see them in the summer and fall off of our coast. They come off of San Francisco Bay, and they've declined a lot, which is unfortunate. In the old days, I've seen as many as 6 in a day, but now I don't think I've seen one for 4 or 5 years, but I'm not spending a lot of time out there. But anyway, they are huge. That head's about the size of a basketball. They weigh maybe a ton. And they're just this ancient old turtle that lives in the ocean, but would show up, and they really like the area where the San Francisco Bay waters come out and meet the real ocean waters. And so we always thought that, okay, where are they coming from? Where are they breeding? Well, we used to assume that they were coming from Costa Rica, where the closest sea turtle nests are for the leatherback turtle. So again, with these tags, they go down. So they went to Costa Rica and put a bunch of tags on down there, expecting some of them at least to come up to our area here. But instead, all of the Costa Rica ones went down to the productive waters here in the Humboldt Current off Chile. So that left open the question, where are our turtles coming from? So to do that, they had to get out there and actually net them off in Monterey Bay or off our coast here somewhere and put a transmitter on. Here's the transmitter, and then release it. And turns out our turtles go to Borneo to nest and New Guinea. So that is another incredible east-west trans-Pacific migration route that we found. So here's a map that shows where the turtles go from Mexico and Costa Rica, and our turtles end up going all the way to New Guinea and Borneo. And it turns out takes about 3 years for an individual turtle to make this entire round trip. And there's also some indication that they're going, a lot of them go to, I'm not sure it's visible on this map, but at least in the early part of the study, it seemed like they were going here first and then going there. So it's kind of like the white sharks, where they go to some ancestral grounds here where there's no food or anything, and then they go to breed. And okay, so why? Always why? It's a 3-year round trip. It's about 17,000 miles. They come here for this. This is Chrysora fuscescens. It's also called the West Coast sea nettle jellyfish. And it turns out this genus has the most nutritious gonads of any jellyfish in the world. And so the turtles come up here, and you see swarms of these things off our coast. This is a video grab I took from the Farallons, where it's just as far as you can see. And I've been on pelagic trips where you just go for miles on the boat and you just see this. So there's this complete abundance of this very nutritious jellyfish here off our coast, and it causes the turtle to come all the way here to feed up. And then there's some speculation that it might sit here and feed up so much, and their metabolism's so slow that it maybe only eats once every 3 years. It doesn't bother looking for food during any of this round trip it takes to get from California to New Guinea and back. So that's the story about trans-Pacific migrations. And of course, the take-home message with all this tagging and whatnot is to figure out what areas of the Pacific are very important for all these creatures, and then to work on developing an international marine life protected program, which, it's going to be hard. There's a lot of countries that aren't going to want to do that. But, I think eventually we can get there. I was part of the process here in California to create marine life protected areas here, and that was hard. Fishermen were not into it. We wanted to, and what they are like areas where there's no fishing allowed. So to allow animals to breed and spawn and reproduce, and then they'll go out from there into areas where they can be fished. And I have some friends who live in Bolinas who are really adamantly against it. And I'd argue with them and say, no, come on, let's give it a try. And then they were really opposed. We'd go to all the meetings and argue and talk past each other and everything. And then they set aside these things. And now these same fishermen are like, I was wrong. It really is working, because a lot of the fish stocks, like of rockfish off our coast and so forth, are really increasing right now. So what we want to do is do this at the international level, and these tags are really helping us discover the areas that would be really good for marine protected zones. Okay, so that's all. And sorry if it's late, I have no idea what time it is. Typically I go way long, but anyway, I'm totally happy to take more questions and hang around for as long as you guys have questions.
Okay, Peter, we have a few questions here. One goes back to the albatrosses. Is there much known about how the albatross stay on course when they're sleeping while they're flying?
It's, well, birds have pretty incredible senses of direction, way better than we do. And the early work on migration indicated that they use several cues. The stars, they're able to read on a clear night, they're able to read the stars. They're able to know where the sun's rising and falling based on ultraviolet light, or what do you call it? Polarized light signals that they can see in the sky. There's some indication that they can hear ultrasound frequencies, which means that they can hear, for instance, waves breaking, big waves breaking along a coast maybe 1,000 miles away, or a thunderstorm a couple thousand miles away that emit these really low frequencies. So it's thought that birds use all of those kind of cues. Sense of smell probably comes into it for seabirds especially. They're probably able to see these cloud formations that occur over islands, and I bet that's a way that they're able to come to islands to look for breeding. So it's a whole combination of sensory things that birds are able to detect that we aren't. And humans are pretty terrible at sense of direction out in the wild. So I think birds got us beat there. But I'm not an expert on that, but that's kind of what I know about it.
And someone wants to know whether either Midway or the Farallon Islands are accessible for people that want to do birding.
Yeah, the Farallons are not. Of course, when I was there, you're restricted to 8 people per night there, and we wouldn't even hit that in the fall. I'd want to keep it at 4 to 5 people. And if birders wanted to come out, they'd all be out there all the time, because it's well known as a place where a lot of vagrant birds end up coming down. These birds fly off the coast at night, and then under certain conditions where it's cloudy and calm, they come down through the cloud layer, and they don't see anything but the ocean and the Farallons. So we got a lot of off course. They're already off course, and so they come down to the Farallons. So it's restricted access for these reasons. Plus the seals and the bird colony and all that stuff means that we just can't accommodate people. There are a few ways you can get out there. You can volunteer to be, a volunteer on the island. And generally we want to have people be there for at least 8 weeks. So that cuts out a lot of people from being able to do that. And now this year with COVID, you had to be there the whole year, the whole season. So the crew that is there now in the fall, I think they got out there in the 3rd week of August, and they haven't left since, and they won't leave for another couple of weeks here anyway. So that's just the way it is there. And then Midway is a little more accessible, and for a while there were tour adventures, and there may still be. You can fly there. Aloha Airlines actually used to do a route from Honolulu to Midway, and that allowed tourist events and tourists to get out there. Really expensive. There's also an albatross count that occurs there maybe it's every 2 or 3 years now. It used to be every year, but that, they're a pretty selective. It's pretty hard to get onto that, and that's what you really want to do. You want to go out there and count albatross for 2 weeks and then come off. But so those are the ways. There may be a way. The Oceanic Society here in San Francisco used to run tours to the Midway, and that's how I actually was funded to do the research, because we had Earthwatch groups and Oceanic Society groups that would come out and help us collect the seabird data. So that's how we actually funded that work.
And is there somewhere you can see that map that shows where the white shark breeding grounds are?
Let's see. We don't know where the breeding grounds are because of the females. We're not able to have tags on females for the full 2-year period. So we don't have an idea there. There is another group that's putting what's called pit tags onto the fins, but you have to catch and reel a shark up onto the deck and then put it on and then release it. So that's become kind of controversial because of, the effect it might have on the shark.
Right. I think the person was asking about you called it the Swingers Cafe, I think, area.
Yeah. Let's see. Sorry, I gotta go back pretty fast and far. There it is. This is in a paper, Jorgensen et al., 2009. I have a PDF of it that I think has this map. So I don't know how I would send it. Maybe I'll send it to you guys and you could pass it on if you want.
Okay. All right. Thank you, Peter.
Mhm.
And do you have can you re-show that page that has the website on it that you were referencing?
Yeah, the top one, right? This one, right?
Yes.
This one's from 2017. So the way websites change these days, it probably looks a lot different now. But
Okay. So is
anyway,
that Census of Marine Wildlife, Marine Life? Is that what
I
you would
would
look
look,
up?
I would Google this one, tagging of Pacific pelagics.
Okay.
And if that doesn't get you there, put in Hopkins or Stanford. I mean, I'm sure it'll get you there.
Okay. All right. Thanks.
Uh-huh.
Let's see. Thank you. Okay, the tracking seems like it would be important for determining impacts on offshore wind, which is planned for areas like off Morro Bay. Are you involved in any of that planning for siting of offshore wind
Yeah, I am
power?
not. I am not. I do have friends at HT Harvey who are working on that. And you know, it's a hard one because we all want carbon free. You know, we want that alternative energy, but then we don't want it to affect the birds. So, you know, I think the solution there is to do a lot of research in the areas that you're going to be putting these things, and then you know, really understand when birds are flying through. And this goes for the windmills like at Altamont Pass and places like that too. Um, and uh, and then have people looking at the weather patterns and tracking migrations with radar. And when there's nights when there's a lot of bird activity, you shut the things down, and then you can start them up during periods of a lot less bird activity. I guess that would be where I would stand on that whole issue right there. You know, because we want the clean energy. So it's got to be a, you know, some sort of a way to do that, but we also want to minimize bird strike.
Okay. And is there anything you can tell us about waved albatross migration from the Galapagos?
No, I don't know, but I'll bet. I think David Anderson, the guy who's doing the all the laysan and Blackfoot tagging, did some down there too. It's my recollection he did, and I don't know where they go. They may not be as dramatic, otherwise we'd know. So they may just go from the Galapagos, which is, you know, right here. They might just go down into the very productive Humboldt Current here. So they may not need to go as far as these guys up here.
Peter, a lot of the other comments I got is just what a great presentation it was. So I want to thank you very much.
Well, thank you all for attending. It's my pleasure.
Okay, well then I guess we'll wrap up, and I want to thank you so much and thank everybody else for attending. Good night.
All right. Have a good evening, everybody.